probably quite largely from the previous talk.
Yep.
Over to you, Tim.
So, hi everyone. My name's Tim. I'm CTO at Paramus. I've been working with OSGi for quite a long time at this point. I'm co-chair of the IoT expert group. I do lots of work with distributed systems, and I've got an OSGi book that has been out for a few years now. But what I'm going to be talking to you about today are services, microservices, and microservices with a mu, because those are all things that get talked about all the time, and people use the terms more or less interchangeably. And it comes down to, what do we mean when we say this thing is a service? And a service is just a bit of software that does something in the most abstract sense. Now, there are all kinds of additional rules you can layer on top, but fundamentally, it's a piece of software that does something. It may be retrieving or updating some stored data. It could be a transformational service that you use to convert data from one form to another. It could give you real-time access to information from the real world, or the ability to affect the real world. Maybe change the state of an automatic door lock. And a long time ago, when we said services, we meant these were web services. Web services being something that we don't really like to talk about nowadays, but that's what they were. And we didn't like to talk about them because they were big. They were coarse-grained things, they were large, they were hard to deploy. There's often just an HTTP front end bolted onto something that you already had. So these things weren't purpose-designed, they were effectively just people exposing something that they kind of already had. And therefore, there were horrible mixtures of APIs, all kinds of different ways of exposing the same sorts of information. And microservices were a way of trying to fix this. Some people say they're an evolution, some people they're a reaction to web services, that microservices came about because web services were so bad, we needed to do something different. And it's all about being much finer grained and having dedicated processes that do something that's been specifically designed to be a small service. And then you build your application from lots of microservices, rather than exposing a ready built application as one big web service. Now, OSGi has had the concept of services for far longer than both of these things have existed. And they were introduced basically as a way to ensure that modules could communicate with one another and remain loosely coupled, so that you didn't have to load implementation types from one bundle in another. You could communicate using services that advertised an API. So this is it's a dynamic thing as well. They represent the changing physical world around the bundles. Services can come and go. And they're basically ultra lightweight microservices, as per microservices from the previous slide. And it's just calling between one object and another. It's in process, and they're actually a really good way to build up microservices that are using some kind of web or REST or something else. But using OSGi services as the building block is a good way to do it. As people say, it's turtles all the way down. So as I said, an OSGi service is just a Java object. There isn't anything actually more special than that. It is a Java object that you can get hold of. It's registered in the service registry, and that includes the service's API. You always register with the thing that it is advertised as. They also have properties. So you see here we've set the foo property to have a value of bar. And this is additional information about what your service is, or what it does, or maybe some quality of service that it has. And it can help your client, if there are multiple services around, it can help your client to find the service that it wants in preference to others. Or maybe you just ignore the properties and say, I'll take whatever you give me. These properties can actually also communicate other information. So these properties are used for things other than client selection. Now, easy ways to get services and publish them. For those of you who were in the previous talk in this room, you'll have been hearing about Declarative Services. It's from the OSGi compendium, and it's basically a container model for registering OSGi services and consuming them, as easily as you possibly can. It gives you automatic dependency management, automatic lifecycle management, and annotation-driven metadata. So you can just put a few annotations on your class, and away you go. Providing a service is really easy. In this case, my component will advertise my service because I've said it's a component and it implements my service. That's all there is to it. Referencing a service is also really easy. In this case, I'm using field injection, but I've annotated my field, my service, to get hold of that service from the service registry. Nothing complicated at all. But there are some new things. So constructor injection, you can actually inject things into constructors where previously you could only use fields and methods. Activation fields, so you can inject your configuration into fields or other types that you would normally receive through your activate method without actually having to have an activate method. And then the other thing I'm going to talk about a bit more than the others are component property types. So these are custom annotations that can define properties for your service. And that makes them really powerful. And you will be seeing more of these. So that's an easy way to publish a service. But the question is, what do you do with services that you've published? Well, one of the things is you can contribute to a whiteboard. And what is a whiteboard? It's basically another way of using OSGi services. So you typically would use a service to communicate between two bundles, but sometimes you want to use them to register some kind of extension or something that needs to be enhanced in some way. So this is what a whiteboard is about. It's about how you can extend classes of service in a particular way. And you use the service property to identify and configure the things that are going to be taking part in the whiteboard. There are a number of whiteboard specifications in the compendium. So these are standard whiteboards provided as specifications by the OSGi Alliance and then implemented by various different projects. For example, the HTTP Service Whiteboard, which exposes servlets and servlet filters and listeners for the servlet specification. In release 7, we'll have JAX-RS services as a whiteboard. And these R7 updates for these specifications actually contain component property annotations, which are designed to make it as easy as possible to use these specifications. So for the HTTP whiteboard, as I said, you use it to provide servlets. So the service properties that you put on these things are the kinds of things that you would normally put into a web XML. So if you write your normal servlet, make it a service, and then add the OSGi HTTP whiteboard servlet pattern property, then you're done. And you may notice that is a horrible long property name. It used to be the case that adding that was a pain. It was easy to misspell it, easy to get it wrong, and you got no real help or type safety with it. So in R7, it's much easier to provide this property because you can just use the annotation. And you know what? The compiler will tell you if you get it wrong. It's brilliant. You can also use this whiteboard to get static resources. So this is, and there is actually another annotation that you can use. Looks quite a lot like that one, and it will allow you static resource access. Now, JAX-RS is obviously another Java EE specification, and it's there to basically make it as easy as possible to write your RESTful services. Now, all we do here is we say, we've got a good whiteboard pattern that makes it easy to register things with a container, it to be extended in some way. Why don't we use OSGi services and the whiteboard, just like we do with servlets, but with JAX-RS resources? It's dynamic, so we can extend our JAX-RS applications at any time. You know, at runtime, we can have things come and go. And again, all we want to do is we want to write our normal JAX-RS resource. We want to make it a service, add, in this case, a shorter property, but add the osgi.jaxrs.resource property. And then with DS and component property types, this becomes really laughably simple. And just to show you how simple it really is, it's time for some code. So I have here a very simple example component, which is slightly larger than it needs to be. You can see here we have our example component. Now, in this case, I've actually had to tell DS to export it as a service using the example class, because we don't implement an interface. Because typically you don't in JAX-RS. You don't have an interface that you advertise. But what we do have is the normal JAX-RS annotations. We have the path saying this will be on the path simple. And we have a method that will respond to GET requests saying hello world. And we have our component property type annotation saying JAX-RS resource. And that's the thing that's going to mean that we have the necessary necessary property on our component. We didn't have to write some horrible string. We didn't have to go native in the component annotation. We can just put that on there, and then away we go. So just to prove it really works, I can resolve this thing, run it, and then here, you can see I've been running it earlier, but this thing is responding to my request. All very simple, right? And that's how easy it is. One of the things that I realized when writing this talk was that I was going to have to do some more complicated stuff, because fundamentally the basics have become so easy that you can't really say OSGi is hard anymore. I put 2 annotations on a simple class, and all of my whiteboard stuff is working, and I can click a resolve button and everything's there. That just assembled my runtime. It did all of it. So I'm going to have to talk to you about some of the other stuff that maybe you'll be interested in. I don't imagine that API versioning is one of the things you're really interested in, but it is quite important, so I do need to talk about it. API versioning is a statement about not only backward compatibility, but also future compatibility. So you should always version your APIs properly. You should use semantic versioning. BND will help you if you use its baselining features. It will make sure that you do this. But unfortunately, there are public APIs that are terribly versioned. You may have noticed that Guava has a single version number. There are random points in the version numbering scheme where they have made breaking changes. So despite the fact that they said we only need one version number because we'll never make breaking changes, they did make breaking changes. You don't know where they're going to be because you have no hope of being able to decipher the version scheme. Java EE specifications also tend to jump around randomly. It is impossible to predict when the next version of a spec is going to be a point release or a new version number. For example, Servlet 4 and JAX-RS 2.1 add approximately the same new functions. It's mostly around server-sent events. For JAX-RS, they decided to go with a point version. For Servlet, they decided to go with a whole new major version of a number. Nobody knows why. So, how do we deal with this? Because it turns out we can't stop Java EE from doing this, because we've tried. I've tried. I've been on at people that they don't care. So what we have to do is we have to work around the problem. And this is where we come up with the concept of contracts. And a contract is an OSGi capability that represents a version of an API, where an API may be a collection of packages. So the client requires the contract at a particular version, and then imports the API packages that they use from that without any version information. So normally that would be really unsafe, and we'd say don't do it. But the contract protects you. And BND can actually detect contracts on your build path and use them for you. So you will see in the component project that I've just been using, you can see in this require capability, I've got a requirement for DS extender, and I've got a, a requirement for the OSGi implementation of JAX-RS, and suddenly here we are, an OSGi.contract for Java JAX-RS. And that's really important because it means that it's also really safe for me to do import package javax was rus, which is where I'm getting my annotations from, with no package version. So as long as I'm with someone who provides the API contract, in this case for JAX-RS 2, which is what I used, what I compile against, what I'm expecting, then everything will work just fine. Even though they've decided that the next one's 2.1 and the one after that, given the Java version numbering, is probably going to be 27.3. So if there are multiple the question was what happens if there are multiple implementations. You will get wired to someone who provides the contract that you want. So if there are multiple implementations and only one of them has the right contract, you'll get that one. If multiple of them have the contract, it's exactly the same problem that the resolver is solving all the time. It will wire you to the one that gives the best, where best is determined through a number of heuristics, class space. Now, CRUD services. So RESTful services often use what are called CRUD operations. This is create, read, update, delete. And this means that you need some kind of way of storing the information, right? So this could be whatever, but fundamentally it needs to be persistent. Now, there are JDBC and JPA specifications in OSGi already. They've been around for quite a long time. I think 4.2 was when they were added. But R7 actually enhances the way that you can interact with these things quite a lot. Automatic lifecycle and transaction management using the transaction control specification. Now, transaction control manages these resources using scopes. A scope can be transactional, meaning it has an associated transaction. It will be atomic, but they don't have to be. A managed resource is bound to a scope, and it can therefore automatically be cleaned up, which means you don't need to worry about resource leaks. You don't need to worry about closing all of your statements and your connections and your entity managers and whatever else. You know that when you use them, it will run through quite happily, and then at the end of the scope, everything goes out of scope and is closed or returned to a pool, or whatever needs to happen to it will happen. Managed resources are created using resource providers, and these resource providers will offer things like pooling for JDBC connections, or even for entity managers. They're something that could be pooled. And there are some standard resource providers, by which I mean there are standard interfaces for dealing with these things in the R7 spec for JDBC and JPA, but it's designed so that you can provide your own resource provider implementations for whatever kind of connection you want. Now, wiring it all together, it's actually not good practice to have your REST service directly coupled to your persistence backend. Because if you do that, then you end up mixing your presentation logic, your how do I want to respond in particular cases, with the actual implementation of how you talk to your persistence store. What if you wanted to change what it was? You don't really want to have to change all your REST services just because you decided to move from one database to another. Also, what if you wanted to stop using a database and instead use, some column store? And this is where OSGi services are really good, because you have reusable modules, you can have different storage types, and then they just communicate in the normal way. Microservices all the way down. Now, I've showed you declarative services as a way to provide a service. DS is actually cool, but it's kind of overkill for just providing a service. Providing a service is actually not that hard. The bit where DS really, really shines is when it comes to consuming services. Annotating your fields, and you're there. You can have activation and deactivation callbacks as well to let you know when things are ready to go. And let's take a look. So let's start with the persistence layer. So that's probably a little big. Let's go down one more. That's still visible at the back. So what we have here is a component. I've made it immediate because it made it a lot easier to tell when I'd messed up my SQL. But it's a library implementation that implements a library interface. So that's going to be advertised as a library service. You can see it gets hold of transaction control, it gets hold of a factory for JDBC stuff, and it gets hold of a data source factory, which is the standard JDBC service. It has some default configuration here, which could come from configuration admin. But importantly, it's just going to, when this starts up, get hold of a JDBC connection provider, which is this transaction control type thing. And it's going to, based on that, get hold of a scoped connection resource. We can then, in this case, require a transaction here and execute a load of stuff that's all going to happen within that transaction. In this case, in our activate method, we're looking to make sure that we set up the database table. We're dropping the old stuff and setting it up with some initial data. The methods themselves look like you'd kind of expect if you're using JDBC, which is not hugely pretty, but not very complicated either. And the important thing to look at is that I'm using that connection object, and I'm not having to worry about getting it to a sensible initialized state, nor am I having to worry about disposing of it. I can just use it over and over and not worry about it. Now, this library implementation is being used by this library REST service. So we're referencing the service in the service registry, and then we've just got some really simple things that allow us to get hold of some information, and in this case, we're producing JSON. So it's going to return this as JSON stuff. And you can see we've got a variety of different useful methods. We've also got the ability to add new books. And what we can do is we can resolve and run this thing. And you can see at this point that I'm able to go and, oh, wait, what's this? Now, as I'm sure you all know, when demos go wrong, it's because it's always deliberate, right? In this case, it really is. And you saw that we were providing JSON. Now, it turns out that there is no JSON support in the JAX-RS spec, which surprises most people when they first hear that, because you think, why the hell would you not support JSON? So actually, what we need to do is we need to tell the whiteboard that we require JSON, and that unless there is something that can serialize to JSON, that it shouldn't use our service. Because it's a really bad thing for it to call our service and then explode because it can't map the types correctly. It would be much better for it to not accept our type at all and register a failure thing saying, this thing can't be processed because you are missing something it needs. That's a much more OSGi friendly way of dealing with the problem. Now, there is a standard annotation for this. The JAX-RS extension select, and then you can give it a filter and you can say, I need an extension that advertises this property. So this allows you to use whiteboard extensions to provide, in this case, a media type of JSON. So that's going to be something that can deal with JSON media types. But it turns out we can actually do even more by defining our own annotations. And this is where I think it gets really, really cool. This is the thing where fundamentally the component property types were amazing, and then I realized I could make my own that were even better. So I should talk a bit more about writing it first. It's easy. You want type target and class retention, typically, because that's all DS cares about when it's scanning for annotations. And then the annotation you've written needs to be annotated with the component property type meta annotation. That's the thing that says to tools, you need to take this into account when processing properties. For a single element annotation, so those are things that have exactly one element called value, so there's some support for making those even nicer to use than just normal annotations, then you uncamel case the annotation name and add dots. So the property name in the case of uncamel case would be un.camel.case. The value is then either the default of the annotation or whatever the user put when they declared the annotation on their class. So you can set a key and a value using a single element annotation really easily. So that's exactly what you saw when we had the JAX-RS resource annotation. That was a single element annotation with a default value. For other annotations, take the name of the property, replacing underscores with dots, and then the value is either the default for the annotation or whatever the user supplied, just like it was before. So you've seen me running resolve on this thing, right? This is using the metadata in the bundles to assemble my application. So my whole demo, I am dynamically assembling the runtime every time I click that button. Now, a whiteboard property is something that takes effect at runtime and expresses a dependency. So in this case, I'm saying I need a JSON thing, but I'm only saying it at runtime if I make a component property type. And actually, I still need there to be something at resolve time. The resolver needs to know that I need something to provide JSON. And this is where you come across the requirement and capability annotations from R7. These are more meta annotations, so you don't have to apply them directly to your component. You can apply them to your own custom annotations as well. And these can be used to add things to the bundle manifest. So our component property type annotation that we create can also add requirements for stuff. So if we go back to the IDE, you can see here that I have a couple of component property annotations. So you can see here I've created my own JSON media type annotation, which has this, go away Jetty, has this OSGi JAX-RS extension select thing with a default that says, give me JSON. And I've also added this requirement annotation to it in my own namespace saying, give me this JSON requirement thing. And that's going to end up in a bundle manifest of anything that uses this component property annotation. So you'll have a requirement on somebody providing that capability. Now, if we've got the requirement, we better have the corresponding capability. And so we have that here. You can see I've got another component property type, which has the media type JSON, so the thing that I want at runtime, but it also says, look, I provide this capability that you're going to need when you're doing your resolving. So as a result, I can do a really silly implementation that you'd never normally bother with because you'd just use one someone else had written. But I have a JAX-RS extension, which says this is an extension to the whiteboard. It's a JSON media type provider, so I'm going to have that capability in my manifest, and I'm going to have the relevant service properties associated with this service. I am a component, and I'm going to advertise some interfaces, in this case message body reader and message body writer. I produce and consume all sorts, because you can use the methods to work it out. And I'm actually delegating to the JAX and JSON provider. So this is just a noddy example for providing a JAX-on JSON message body adapter. But it means that if I go back to my library REST service and I annotate it with JSON media type, so this thing is now going to require that guy. So next time that I resolve, Now, what you probably can't see at the back, but you can hopefully see at the front, is suddenly I've got requirements for various JAX-on things and my JAX-RS extension, and you can see it's been required because I have this requirement on the JAX-RS media type being JSON. And all of that happened just because I used those couple of annotations in my components. So you can write your own custom annotations and use them wherever they're needed. So now, if I resolve and save and start running again, and we take a look at the authors, you can see it works. It actually gives me something. And that means that I can, if I reload this page, see a UI which is making use of that library. So it's showing me the books that are in there. So those were the things that I added automatically, but I can add more stuff. Question is, which Eclipse was it? So this one's still working. Yeah. So you can see here that I'm able to use my REST microservice, and just to go back and show you what it's interesting. It looks like it really was the one I was using. That's going to be a pain. So what I was going to do was show you just the annotation that I'm using to provide all of this. So it's one of the HTTP Whiteboard annotations, which is basically just setting up the static resources that I'm serving from my bundle, just using an annotation. So again, you don't have to build up this stack of component properties in your component annotation anymore. But as it is, I think instead, I should probably go back to my presentation, if only because I've given you a really brief overview of some of the cool stuff you can do and how easy it is to start assembling these applications. It really is now a case of just put a few annotations on things and suddenly magic happens. But you can do other cool things. So the JAX-RS Whiteboard, I've been showing you whiteboard extensions and whiteboard resources. It supports application services as well. You can provide fully or partially configured applications to the whiteboard, as well as just individual resources. You can do this to scope and target things. So if you've got a multi-tenant server, you can have your own application and know that other people aren't going to interfere with it. Transaction control can do an awful lot more than I showed you in about 2 minutes just now. So I suggest you go and take a look at it. You've got the ability to do detailed rollback control, nested transactions, there's support for XA recovery if you care about it. OSGi PushStreams are really cool. If you've not been at one of the talks talking about them, then you should take a look at them. They're really good for server-sent events that are in JAX-RS 2.1. And then you've got, obviously, the ability to make use of dynamic services, remote services, asynchronous services. There are so many cool things. You really should look. So, at this point, I'm going to ask if there are any questions. The most obvious ones I could think of were, where can I find out about this stuff? So, R7 specs are available in draft form, which includes basically all the stuff that I've just been talking about. You can make use of the whiteboard that I've been using. It's available from Apache snapshots. All of the APIs I've been using are available from the Sonatype OSGi snapshots. Yeah. So the actual code needs a little bit of tidying up, and then it'll become another one of the Paramus examples. The only thing is, at the moment, obviously, it depends on a bunch of snapshot stuff. No. Yeah?
Can the transaction control that you showed in the presentation be used with the entity manager in JPA?
Yes.
So instead of having these nasty annotations transactional, I can use directly the
Yes, exactly.
Okay.
So yeah, the question was, can you use the JPA entity managers instead of JDBC connections? And the answer is absolutely yes.
you also use these transactions across bundle boundaries?
Do the transactions apply across bundle boundaries? Yes, they do, because the transactions are associated with the transaction control. If you have two bundles using the same transaction control service, they inherit the same scopes all the way through. So,
I suppose I have to make sure that only one implementation of the transaction control exists.
well, you need to make sure that things that should be participating within the same scope are using the same transaction control service. Typically, you would only have one. It doesn't make a whole lot of sense to have several of them. But if you do have several, the main thing is to be careful. You can use filtering to make sure that you get the same one across bits that you care about. But as with all things in OSGi, most of the time you would expect to see one. You can cope with having multiple, but be aware that you're making it harder for yourself.
So in the transaction example, you had a method that calls another method.
Yep.
And the second one, if I understood correctly, was saying supports.
Yep.
Is that how you always have to do it? Is like if you just call the method that part of that doesn't participate in the transaction?
No, it does, but the method that I was calling that had supports was also a part of the public interface. So people could call just that method. So I have supports on there because it needs there to be a scope. It just doesn't require it to be transactional. But I was reusing the implementation of the method from within the startup thing that needed a transaction. So you put... No. You put it there if that thing is accessible publicly and therefore needs someone coming in to acquire a scope. Yep.
In the bundle with the annotations, about JSON, you put the requirement capability annotation.
Yep.
So this bundle doesn't have the unexposed capabilities and requirements. So I mean, that's kind of the one where you define the annotation. I guess it's not saying that I can just on that.
So that one, that bundle, ideally you would make non-resolvable because normally those annotations are only to be used at build time, so that bundle itself is kind of runtime useless.
Okay, so you don't have any kind of thing that says if it's an annotation, it doesn't go through. Okay, you make this.
Yeah.